Okay, so welcome to section 3.4, which is the trigonometry of real numbers. So the trigonometry of real numbers. And you might say, well, what does that mean? And you would be right to ask that question. So usually we take sine, cosine, tangent of angles. But remember, if those angles are in radians, radians are actually real numbers, so note. So radian measures, radian, which is how many radii on the circumference we have swept through. So radian measures are real numbers. So measures, actually I want to say are unitless, right? They have no feet or degrees or anything attached, so they are unitless. That is, i.e. it est n radians. Radians is equivalent, 3 equal signs means equivalent, to some number n, a real number, right? So n is an element of the real numbers, that's what that means, but in English we say is equivalent to a real number n. Okay, so let's recall. And let's go ahead and use our symbol sheets some more. But we've been through what all these symbols mean. So for all theta who in absolute value have a measure greater than 360 degrees, this implies that theta is equal to, or how do I want to say this? Yeah, I'll say theta is equal to phi plus or minus 360 degrees times some integer k. So some integer k would be written k is an element of the integers. So where phi is in the same position as theta is in the same position, because if I go full circle, I'm right back to where I began, as theta on the unit circle. So on S1, the unit circle. Okay, so let's consider, what do I mean by this? So let's consider some angles that are greater in absolute value than 360, which is equivalent to 2 pi. So let's say we have, I don't know, let's do 39 pi over 6. Well, I claim that 39 pi over 6 can be thought of as 3 pi over 6 plus 12 pi over 6 plus 12 pi over 6 plus 12 pi over 6. So let's see, 12 plus 12 plus 12 is 36, and 3 is 39. So that is, this is 3 pi over 6 actually reduces to what? So 3 goes into 3 once and into 2 twice. So this reduces to pi over 2 plus 6 goes into 12 twice, so 2 pi plus 2 pi plus 2 pi. So do you agree that this is pi over 2 plus 2 pi times the integer 3? So that's the k in this case. So this would be equivalent to pi over 2 on the unit circle. So 39 pi over 6 is equivalent to pi over 2 on the unit circle, because really it's pi over 2 and I go full circle 3 times beyond that. So let's see another quick example. So I did pi over 6 that time. Let's do 33 pi over 4. Okay, so I claim that this is 1 pi over 4 plus 8 pi over 4 plus 8 pi over 4. So 8, 16 plus 8 pi over 4, 24 plus 8 pi over 4, 32 plus the 1 left over. Okay, so I can write this as pi over 4. 4 goes into 8 twice, so this is 2 pi, that is a full revolution, plus 2 pi, that is a full revolution, plus 2 pi, plus 2 pi. So I've gone full circle 4 times beyond pi over 4. So this is pi over 4 plus a full revolution, 2 pi, times the integer 4. So 4 full revolutions beyond pi over 4. So I claim that this is just equivalent to pi over 4 on the unit circle. So that is 33 pi over 4 is equivalent to pi over 4 on the unit circle because I've just gone around 4 more times. So theorem. Should I use a darker purple for theorem? Okay, so theorem. Okay, so for all angles theta who in absolute value have a measure larger than 2 pi radians, let me actually write my for all a bit better. Wow, that is not a bit better. Okay, let's see if I can do this. So for all, there we go. That looks a bit better. This implies that the point cosine of theta, comma sine of theta, is equivalent, so 3 equal signs is equivalent to cosine of phi, comma sine of phi, where, of course, theta is going to be phi plus or minus 2 pi k, right? So where k is some integer, and so like we had the above, this is our phi, and our theta on the left-hand side, right? So, and where is phi? Phi is between 0 and 2 pi. So it's on the interval between 0 and 2 pi. So basically I'm just restating what we have above. So I can, the point cosine of phi, comma sine of phi, which is on the unit circle, is the same as the point cosine theta, sine of theta on the unit circle. So for example, so evaluate these 6 trig functions, or these 6 trigonometric functions. Metric functions of, let's have theta being equal to, what should we do? 11 pi over 3? That sounds good. Okay, so let's look at theta. Theta is 11 pi over 3. So I'm going to write this as, well, pi over 3 twice pi over 3. Okay, so I'm going to write this as 5 pi over 3 plus 6 pi over 3. That's 11 pi over 3, right? But notice that 6 pi over 3 is 2 pi times 1, right? So that means that the phi that has the equivalent position on the unit circle is going to be 5 pi over 3, which is the 60-degree reference angle in quadrant 4. So what is a coordinate for the 60-degree reference angle in quadrant 4? Let's do it in pink. Well, I know that 60 degrees is 1/2 for x and root 3 over 2 for y. So in quadrant 4, x is positive, so 1/2, but y, the root 3 over 2, is negative. Okay, so let's go ahead and evaluate sine of 11 pi over 3. Well, I claim that that's equivalent to sine of a 5 pi over 3. Oops. Because it's just going full circle from there. Okay, well, sine is the y-coordinate, and the y-coordinate is negative root 3 over 2. So the reciprocal cosecant of 11 pi over 3 is going to be equal to negative 2 over root 3 if I don't rationalize. Okay, so now let's look at cosine of 11 pi over 3. Well, we know that that's equivalent to cosine of 5 pi over 3, which of course is the x-coordinate at that point, so that would be positive 1/2. So the reciprocal, which is secant of 11 pi over 3, I just take the reciprocal to cosine, which is positive 2. So tangent of 11 pi over 3, that's going to be equivalent to, where am I? Tangent of 5 pi over 3. Okay, and that's just a quotient of the two numbers above, so that's minus root 3, because the 2's reduce. Okay, so the reciprocal cotangent of 11 pi over 3. I just flipped this upside down, so minus 1 over root 3. I don't care about rationalization. Let's see, do I have enough room? Let me see if I can force enough room here. Maybe not, I don't know. Can I put another example beneath this? Let's see if I can. So example. So evaluate the 6 trig functions. Trig functions of theta equal to, what shall we do this time? I don't know, 9 pi over 2? Okay, so theta, 1, 2, 3, oh, I'll do it here. So theta, which is 9 pi over 2, can be thought of as 1 pi over 2 plus 4 pi over 2 plus 4 pi over 2. So that's going to be pi over 2 plus 2 pi plus 2 pi. So that means that our corresponding angle phi between 0 and 2 pi is pi over 2. So the coordinate at pi over 2 is 0, 1. Agreed? Let's see, yes, I can move things up so I have a bit more room. Doesn't look so cramped. I don't know, how does that look? Does that look too cramped? I don't know. Let's see, let's move things up a bit. Just one line. I think one line will give me enough room. Okay. That looks a bit better. Okay, I think I have enough room, hopefully. Okay, let's see. So sine of 9 pi over 2 is going to be equivalent, 3 equal signs, to sine of pi over 2. And that is just the y-coordinate. So that's 1. So the reciprocal to sine, which is cosecant of 9 pi over 2. I just flip 1 upside down, so I get 1. So now cosine of 9 pi over 2 That's going to be equivalent to cosine of pi over 2. Well, cosine of pi over 2 is the x-coordinate, so that's 0. So the reciprocal, secant of 9 pi over 2. I flip 0 upside down, 1 over 0. Well, I know that thou shalt not divide by 0, so that does not exist. Now tangent of 9 pi, where am I? 9 pi over 2. That's equivalent to 3 equal signs, equivalent to tangent of pi over 2, which is a quotient of the 2 above it. Well, since thou shalt not divide by 0, this does not exist. Now the reciprocal function, cotangent of 9 pi over 2. Well, cotangent is x over y. 0 over 1 is just 0. Okay, let's see. So, for example, let's evaluate the 6 trigonometric functions. So, evaluate the 6 trig functions. Trig functions of theta equal to, what shall we do, 25 pi over 6? 25 pi over 6. Okay, so theta, which is 25 pi over 6. I'm going to write this as 1 pi over 6 plus 12 pi over 6 plus 12 pi over 6. So that's going to be pi over 6 plus 2 pi plus 2 pi. So I've gone 2 more revolutions, but since they're full revolutions, I just come back to phi at pi over 6, which is 30 degrees. So that has a longer x-coordinate, root 3 over 2, and a shorter y-coordinate, 1/2. Okay. So I know that sine of 25 pi over 6, 25 pi over 6, is equivalent to sine of pi over 6 in quadrant 1. So that is the y-coordinate, which is positive 1/2. So the reciprocal, cosecant of 25 pi over 6, is going to be, the reciprocal to 1/2 is just 2. Flip it upside down. So cosine of 25 pi over 6, 25 pi over 6. That's going to be equivalent to cosine of pi over 6, which is the x-coordinate at that point. So that's a square root of 3 divided by 2. So the reciprocal function, secant of 25 pi over 6. Well, that's going to be the reciprocal. So 2 over root 3 without rationalizing. Finally, we have tangent of 25 pi over 6. So that's going to be equivalent to tangent of pi over 6, which is just going to be the quotient of the 2 above it. So I see the 2's reduce, and I'm left with 1 over the square root of 3. Taking the reciprocal, that is cotangent of 25 pi over 6. I just flip tangent upside down, so I get the square root of 3. And there we are. Okay, let's do another one. Example. So let's evaluate the 6 trigonometric functions. So evaluate the 6 trig functions of theta being equal to, what shall we do this time? How about negative 5 pi over 3? Did I just do over 6? I did over 6 already. So negative 5 pi over, let's do 4. That sounds better. Okay. So theta is now negative 5 pi over 4. Okay. So I claim that that's going to be, well, if I subtracted 8 pi, let's see, 3 pi over 4 minus 8 pi over 4. So this is really 3 pi over 4, which is in quadrant 2, minus a full revolution, 2 pi. So the equivalent on the unit circle, phi between 0 and 2 pi, is 3 pi over 4, the 45-degree reference angle in quadrant 2. Well, thank goodness 45 is just root 2 over 2, comma root 2 over 2. But the x-coordinate is negative in quadrant 2. So I just tack on a negative for the x-coordinate. So we have that sine of quantity, use parentheses, negative 5 pi over 3, is going to be equivalent to sine of positive 3 pi over, sorry, that's negative 5 pi over 4, not 5 pi over 3. Do as I say, not as I do. So sine of 3 pi over 4. So that's just going to be the y-coordinate at that point, radical 2 over 2. So I take the reciprocal, which is cosecant of quantity, in parentheses, negative 5 pi over 4. So the reciprocal, I just flip upside down. This is going to be root 2 when anti-rationalized. Okay. Cosine of the quantity, negative 5 pi over 4. Well, that's going to be equivalent to cosine of positive 3 pi over 4, which of course is just the x-coordinate on the unit circle, so that's negative root 2 over 2. So the reciprocal, secant of the quantity, negative 5 pi over 4. Well, I'm going to flip cosine upside down, so negative root 2. And then tangent of the quantity, negative 5 pi over 4, is equivalent to tangent of 3 pi over 4. Take the quotient of the two above, and I'll get negative 1. Because they're both the same, so that's, at least I can do that one in my head. So cotangent of the quantity negative 5 pi over 4. I just flip negative 1 upside down. Negative 1 upside down is still negative 1. Okay, so let's change it up just a bit. So for example, what should we do? 5 comma 13 comma negative 12 over 13 be on the unit circle. Notice what I say versus what I write, corresponding to theta. Evaluate the 6 trigonometric functions, these 6 trig functions of theta. Okay, well, sine of theta is just the y-coordinate. So the y-coordinate here is negative 12 over 13. The reciprocal, cosecant of whatever the angle theta is let me write theta a bit better, is just flip sine upside down, so negative 13 over 12. Cosine of the angle theta, well, cosine is the x-coordinate, so that's going to be 5 over 13. So the reciprocal function, secant of theta, I am going to flip cosine upside down. So I get 13 over 5. Tangent of the angle theta. I can just take the quotient of the two guys above him. So I notice that the 13's reduced and I get negative 12. Oops, wrong color. Let me go back to orange. Sorry, why am I using this color? So this is going to be negative 12 over 5. And the reciprocal function, cotangent of theta. I'm going to flip tangent upside down, so I get negative 5 over 12. And there we are. Those are the 6 trigonometric functions. If I know the point, but not necessarily the angle, as long as the point is on the unit circle, I know x and y, which means I know sine and cosine. Or cosine and sine, rather. Okay, so let's let... what should we do? 3 comma, or 3 over 5 comma negative... No, I already did. Yeah, okay. 4 over 5. Let's just have it be that. Both positive, so I'm in quadrant 1. Beyond the unit circle, corresponding to theta. So let's evaluate. Once again, the 6 trig functions of theta. So the 6 trig functions of theta. Okay, that's x and y, so we already know our sine and cosine. So I have that sine of theta is just going to be the y coordinate if I'm on the unit circle, so that's 4/5, which means the reciprocal, cosecant of theta. Let me write cosecant a bit better. Cosecant of theta is just going to flip sine upside down, so I get 5 over 4. Cosine of theta is the x coordinate. So I get 3 over 5, which means that secant of theta, which is flipping this guy upside down, secant of theta is just going to be 5 over 3. Equals 5 over 3. Tangent of theta. Well, that's a quotient of the two above. The 5 cancels. I'm left with 4 over 3. And the reciprocal, cotangent of theta. I flip tangent upside down and I get 3 over 4. Okay, so there we are for those. Okay, now let's do something a bit different. So, for example, so suppose that tangent of theta is negative square root of 3, and theta is in quadrant 4. So find theta. Okay, so I know that tangent of theta, tangent of angle theta, well, that's negative root 3. Okay, so what I'm going to do, I know that tangent is sine of theta over cosine of theta. So I'm going to write this as negative root, actually, what I'm going to do is write this as a sine, which is negative root 3 over 1. That's what I have so far, because any whole number can be written as over 1. But I also know on the unit circle that the root 3 and the 1 are usually divided by 2. So negative root 3 divided by 2 all over 1 divided by 2. Note that that's equivalent, because whatever I've done to the numerator, I've done to the denominator. The 2's would reduce. But now I know that this is the point. What point is this? This is the point where x is 1/2 and y is negative root 3 over 2. And that is indeed in quadrant 4. Okay, so what is the angle that corresponds to that? Well, if the x is shorter and the y is longer, that means that it's a 60-degree reference angle. But since I'm in quadrant 4, I'm at 5 pi over 3. Remember, 1 pi over 3 is 60 degrees. And 2 pi is full circle, which would be 6 pi over 3. So 1 pi over 3 shy of that is at 5 pi over 3. Do I have enough room to do another example? Maybe if I move this up a bit. Let's see. Let's move these up just one line. Let's do one more. So suppose cosecant of phi, let's make it a phi this time, is the square root of 2. And phi, let's have phi be in quadrant 2. So find phi. Okay, so I've got cosecant of phi is the square root of 2. So I'm going to write this as, how do I want to say this? 1 over the square root of 2 over 2. Which is not easy to see, so how do I want to say this better? If I take the square root of 2 and rationalize it, do you agree that this will give me the square root of 2 over 1, which when I rationalize gives me 2 over the square root of 2. Well, that looks like it's sine upside down, right? So this means that sine is the square root of 2. Sine of phi is upside down, root 2 over 2, because s's and c's go together. So I'm looking for an angle where sine of phi is root 2 over 2. So I know that that's got to be a 45-degree reference angle, but since I'm in quadrant 2, the 45-degree reference angle there, well, 1 pi over 4 is in quadrant 1, 2 pi over 4 is the quadrantal angle 90 degrees, so 3 pi over 4. That's what I'm looking for. 3 pi over 4 is the 45-degree reference angle in quadrant 2. So I hope this makes sense, and I'll see you guys in the next video.